Hello and welcome to the Invader Historical Foundation YouTube channel. I'm Jonathan Claiborne. This video is going to be a little different and aimed mostly at historians and archivists who research for small museums and libraries. This video is presented on behalf of the newly formed Aviation History Research Network. We'll be publishing videos and white papers on research methods periodically, and I'll put them all into a playlist so that they're easy to find. This video is a presentation of a white paper that I wrote on the same topic and published earlier this month. My hope is that it will help small museums and libraries in managing their collections more efficiently. Almost all of the scholarly research on this subject, facial recognition, centers around either the abstract concepts of uniqueness of human physiology of facial features or around applications of this technology for law enforcement and security purposes. To our knowledge, no other museums or historical research groups are actively using facial feature recognition to assist with historical research, which makes the lessons that we have learned here somewhat unique in perspective. In this video, I'll discuss some of the unique benefits, challenges, and processes that I've pioneered in my attempts to use these tools for historical research. Many people are familiar with the concepts of facial recognition technology thanks to its prolific appearance in movies and television shows. It is most often depicted in crime and thriller genres where a photo can be scanned and the face can be mapped and then checked against a master database to determine who is in the picture. This makes for exciting television, but the real-life value and limitations of the technology are far more complex. Facial recognition software uses computer algorithms to examine and evaluate a person's face for specific, unique details. These details can include things such as the length of the nose, the distance between the pupils, the width of the eyes, the distance and angle between the eyes and the corners of the mouth, the distance and angle between the corner of the mouth and the nose, and so on. These unique points are mapped and then turned into a series of lines and points with numeric values called a template. The template is the only thing that is used by the software to make an identification. Different facial recognition software produces different types of outcomes. Some facial recognition programs will tell you if a photo's template is a positive match to a known sample on file. Other systems will use a ranked percentage, and the results may display a list of possible matches with the most likely match appearing first. The following image depicts how modern facial recognition features are mapped onto a template. Each point on the face is marked based on a predetermined set of criteria, and then the lines between those points are drawn and measured both in length and angle. The higher the resolution of the source image, the more dots can be accurately mapped, thus giving the face a more accurate result. There are two primary types of errors that occur with the use of facial recognition technology. The first of these errors is a false negative. This occurs when a facial recognition software fails to match a template to a known sample. In this case, you have a known good photo of the subject in your database that is properly tagged and coded, and the new sample image also contains the same subject, but the facial recognition software fails to produce a match. This is most often the result due to system limitations, which we'll discuss in more depth throughout the video. The second error is a false positive. This is when facial recognition technology asserts that two sample images contain the same person, but they are, in fact, different people. In this case, an image of an unknown subject can be mistakenly linked to a completely different person because they happen to share enough similarities in their facial features. This error is also due to system limitations. One of the limitations of facial recognition technology is that the recognition data can be prone to error, which can create false positives. Facial recognition software is particularly bad at recognizing persons of color or in other ethnic minorities and young people often misidentifying or failing to identify them. Keep in mind that anytime you are trying to use photos of these groups of people, it may prove problematic. However, some elements of these limitations can be addressed through more advanced AI software, machine learning, and software training. Facial recognition systems often struggle to make an identification when the photos are less than optimal, which unfortunately is often the case for those of us doing historical research. Some of the common factors can hinder photo analysis and include poor lighting, low image resolution, or poor angle of the subject of the photo. Another limitation of some systems are that the system will not recognize certain faces. For example, in the photo depicted here, Google Photos will only recognize the single face in this image despite there being 8 people. This is due to a combination of factors of low resolution, poor lighting, and suboptimal angles. This image is representative of many of the types of images that will be encountered by researchers. Pictured here is another example of a person who is not detected by the facial recognition algorithm used by Google Photos. Of the 7 people pictured, 6 of them have been identified as having faces, but the other man is invisible to the system. This is again due to the combination of low resolution, poor lighting, and the fact that the face is partially obfuscated by the hat brim, concealing several of the features that the system would use to create the facial template. This photo is one that highlights the limitations of the facial recognition technology when used in historical research applications and presents a special kind of frustration to the researcher. To a human researcher, this face is clearly visible, and in this specific example, the subject of the photo is known to me by name, unit, and location. However, due to the low quality of the photo and the poor lighting on the face itself, the Google photo algorithm does not recognize the face at all. Thus, despite knowing all of this subject's information, it is impossible to tag the photo and attribute the face properly. To add these details to the face, researcher must be able to select the face first, which in this case cannot be done. When evaluating a facial recognition system for use, it is strongly recommended to do a series of test runs on the platform. Understand that no system is perfect and that every system will generate some false positives and false negatives. At a minimum, provide the system with 2 or 3 dozen known decent quality photos of identified subjects. Portrait shots are excellent for this benchmark. Then feed the system a random sample of 2,000 to 3,000 images. This sample batch should include other known photos of the individuals in your known good sample database. Ideally, you should know how many photos of subject A you gave the system and how many photos of subject B and so on, and then you can measure how accurate the results are based on how many results it gave you for each of the subjects. Once all of the known subjects have been counted and measured, a score can be assessed. It is also important, to an extent, to understand which type of errors are more permissible for your use case. For example, would you rather have the system show you false positives more often, potentially linking unrelated people, or would you rather have the system generate false negatives and not match any photos? Take this into consideration when assigning your evaluation score. Although facial recognition algorithms are continually advancing and improving, facial recognition technology should be used to aid humans in their decision-making capacity rather than replace it. Human oversight with the use, settings, and results of facial recognition technology helps to mitigate the risk of errors by double-checking. One problem that is especially troubling in the field of historical research is the potential lack of known good images. Many times, photos are presented to us in a collection of random photos, usually gathered from the estates of people who have passed away, and there is often no accompanying information regarding who is in the photograph. Or, Alternately, the photo may bear a name with it, but due to the age of the photo and the camera limitations, the photo may be of too low quality, making it difficult to work with. One of the best practice approaches in this context is to attempt to find family members of the people you are attempting to identify. If anyone on Earth has a higher quality image of the person or persons of interest, it would be their family. If they're willing to scan a high-resolution copy for you, this will greatly improve your chances of finding successful matches. As mentioned above, many times photos come to the researchers only after the photographer or owner of the photo has died. And in many cases, there is little or no contextual information about the photograph recorded, so the details are a mystery. Forensically, the photo can be examined for contextual clues. Are there unit markings on the planes? Are people wearing unit insignia on their uniforms? Is there a specific building or landmark which can give away its location? Are there other known people in the photograph? Sometimes, by having the answer to one or more of these questions, the rest of the answers can be determined, or at the very least, estimated within a more narrow range. The best possible resolution for this context problem is to have a database that is as large as possible. However, it should be noted that some facial recognition software, especially free services, do have a limit on how many faces it will track. To this end, the number of supported faces may be a key factor in deciding which facial recognition technology to employ. If you are conducting research on one specific unit, then a facial capacity of 1,000 or 2,000 faces may be entirely sufficient. However, if you are conducting broad research that encompasses multiple units, time periods, and countries, you may need a platform that supports tens of thousands of faces. The problem of scattered records is not necessarily unique to historical research, but it is a situation that historical researchers need to be acutely aware of. Due to the compartmentalized nature in which historical records are kept, there is no central database of faces. Even within the realm of photographic collections, there do not exist any single-point collections which are all-encompassing for a given topic. Photos may be spread out through multiple document types, including personnel files, accident files, unit history files, news images, etc. Due to the ad hoc nature by which photos are often acquired and added, a negative result today does not always mean that the result will be negative forever. For example, if a researcher runs a group photo through facial recognition system and only 3 people are identified today, that does not mean that all of the people cannot be identified in the future. Hypothetically, 6 months from now, that same researcher may add 200 more personnel file images to the platform, and several of the other people in that photo may become known. To that end, it is crucially important that whatever platform you select continually runs the searches on a recurring basis in the background. In this way, it will help find new matches over time. If the platform only executes a particular search once, then the researcher must manually repeat the search process, which can become unwieldy as more and more records are added. With the specific limitations and challenges outlined in this video, you may be forgiven in thinking that attempting to use facial recognition technology in historical research is a futile endeavor. However, this is not the case. In the following pages are several real-world case studies that I'll be presenting from the Invader Historical Foundation's attempt to use facial recognition. These case studies will provide a clearer example of the benefits and possible pitfalls of this technology. For all of the studies used in this, the subjects come from the 13th Bombardment Squadron Historical Archives, from the Korean War in particular. This photo set is comprised of 41 separate collections of photos taken by 37 different photographers, spanning the years between 1946 and 1955. In total, the combined target photo set contains 1,993 images, and the total photographic database contains 16,193 images. The facial recognition analysis results for all of these case studies were performed by Google Photos' built-in facial recognition system, which is a free service. No other tools were used in these examples. The analysis of Colonel William G. Moore's results starts with this single photo. The photo provides his name and rank and provides a reasonably good frontal portrait shot with adequate lighting and resolution considering the age of the photo. This photo was provided as part of the Robert Fortney collection, but no additional details were present. The file name simply reads Moore William G. Colonel, which matches what is determined from the photo. Whenever possible, photos like this should be used as a base photo for facial recognition. Counting the photo used as a base image, Google results returned 34 matches for Colonel Moore. This match also comes from the Fortney collection. However, the file name is Group and Squadron Staff. There are no accompanying notes to indicate who any of these people are, but Colonel Moore is clearly visible in the front center of this image. In this case, the facial recognition software correctly identified him and gave us another known photo of Colonel Moore that we might not have known about otherwise. This photo, also from the Fortney collection, is simply labeled Group Staff at Colonel Moore's quarters. There's no additional context or names provided. However, once again, the Google facial recognition algorithm has successfully identified Colonel Moore despite him facing sideways relative to the camera. As with the previous photo, this is another photo that was not clear where Colonel Moore was, but he has now been clearly identified. This photo comes for the Matter-Canich collection. The photo is labeled Gunner Gregory and Driver. It's clear that the two men in the center of this image are the intended subjects, but there, on the far right edge of the image, is Colonel Moore, who just happened to be walking by when the photo was taken. In this case, Matter-Canich did not tag Colonel Moore in the photo's details, but we now have another positive photo, and this time from an entirely different photographer. This photograph comes from the Ray Anastos collection. The photo is labeled Johnny Grubbs, blank blank, A. Landrum. In this case, Anastos did not know the names of the two men in the center of the photo. The third man is turned away from the camera, but the second man can be identified as Colonel Moore. This adds yet another positively identified photo of the colonel, this time from a third photographer, that would not have been known without the aid of facial recognition. Unfortunately, this represents the last of the positive IDs for Colonel Moore. The rest of the images were all false positives. Rather than display the entire image, here's a collection of the misidentified faces for Colonel Moore. As you can see, several of the men from the false positives do share broadly similar facial structures: a pointed chin, a long thin nose, a high forehead, similar face shapes. But these men are obvious to human observers as not being the same person. The benefit of the system, and something that any facial recognition system should permit, is the ability to remove these faces from Colonel Moore's results and unlink them. By doing that, these faces are returned to the results pool and can be manually created as a new person. Part of these mixed results are due to Google's limitations as a software, and the rest are due to the conditions within the photos themselves. Speaking to the Google technology, this facial recognition system was never intended to be used by researchers who are searching through thousands of photos. Google created the facial recognition algorithm with personal end users in mind. In reading through Google's help forum about this topic, it seems that some users cannot have more than 256 different faces in the system at once, while other users can maintain as many as 1,000. But no users reported being able to support more faces than that. This means that since Google algorithms are limited to a specific number of matches, the system is trying to shoehorn everyone it encounters into that fixed number of faces, which is resulting in a higher number of false positives. Shopping around for a commercial system that supports a larger number of faces will be one way to prevent this issue. Limiting the photos to use only Google. Alternate strategies may include uploading smaller batches of photos. Although the subject of this case study was one person from the Korean War, the photos tried to pull in results from World War II as well as results from the 13th Bomb Wing, neither of which were correct in any way. By limiting the facial searches to one smaller group at a time, it may be possible to reduce the number of false positives because those photos are removed as possible matches. As with Colonel Moore, there is a relatively clear photo of Major Estes B. Sherrill with his face in full frontal view. This photo comes from the Fortney collection and is clearly labeled Sherrill Estes B. So here we have a good photo base to work from. The second photo also comes from the Fortney collection. This photo was presented as part of the Colonel Moore case study. The photo caption reads Group and Squadron Staff, and the facial recognition system identified Major Sherrill in the bottom right corner of the image. This is not a known detail without this technology. This image comes from the Matakanich collection and is merely labeled Unknown Major Number 2. However, this is clearly Major Estes B. Sherrill. This is a third photo that would not have been known without this technology. This image also shows from the Matakanich collection and is simply labeled Unknown Major. Facial recognition has once again correctly identified Major Sherrill. This adds a fourth known photo of the Major to our collection. Unfortunately, this is where our list of actual positive results ends. As in the case of Colonel Moore, the remaining 5 results for Major Sherrill are false positives. This example, as with the previous case, illustrates the importance of having a human researcher double-check the facial recognition results. While some of these false positives do bear a passing resemblance to Major Sherrill, some of these faces are not even close. This reiterates the limitations of the system. Had a more complex commercial-grade system been employed for this test, the results would very likely have been different. But since Google's algorithm is limited in the number of total faces it can support, it tries to put every face it encounters into one of the existing profiles. As before, many of the same techniques can be employed to combat these results. Use a better system if possible, or if not possible due to budgetary or technical constraints, use smaller photo sets within Google and rotate them out on a regular basis to keep the number of false positives low. This photo of Second Lieutenant Robert J. Ramsey is from the Ray Anastos collection. It provides a reasonably good base image for use. The photo is labeled Ramsey Robert J. MIA. His rank can be deduced from the pin on his cover. This photo is from the Fortney collection, and the facial recognition algorithm has identified the man on the far right edge as Second Lieutenant Ramsey. This is further supported by the presence of the same ring on the subject's left hand. In this case, the Fortney photo is labeled Marine, Wells, Rulin, Murray, Hambrick, Marine, Adamak, Ruth, and Ramsey. So we can confirm that this is correct. But even in the event that all of the photo details were lost or missing, a positive ID of Ramsey would still have been made. Of all of the photos present, the other 4 were false positives. In this case, the software did not identify any previously unknown photos of the subject, but it did help to confirm the IDs presented with the captions of the photos. As before, the false positives are displayed here. These men bear some broadly similar facial features to Ramsey, but as in the other cases, to a human researcher, it is evident that they are different individuals. The same mitigation techniques previously discussed will be useful here as well. One thing that was a surprise in using the Google Photos program is that it not only attempted to group faces, but the software also attempted to create groups of similar images based on the topic of the photos themselves, albeit sometimes with hilarious and unexpected results. The following list shows a series of AI-created photo groups that Google created by itself from the available photos without any user input. Some of these categories are useful, and some are ones that may not have been considered initially. However, some of them are rather comical. Camping, for example, depicts a series of large tents that served as the enlisted men's quarters during World War II in Korea. Technically speaking, it could be regarded as long-term camping, but then there are the sailboats. As can be seen, the algorithm here also returns false positives. In conclusion, as with any tool in the researcher's arsenal, facial recognition technology can be employed to some success and may assist researchers in positively identifying unknown individuals. However, the results of such work should never be blindly accepted and always verified by a human researcher. A higher degree of success can be found by utilizing best practices and by understanding the specific limitations of the platform that is being used. I hope you found this video exploring the use of facial recognition technology as a tool for archival research helpful. Until next time, thanks for watching.